What's this? We're going. We're good. We're live. Okay, I think we're live now. Oh, they changed the UI on me again. And they always change the UI on me. How do I change the title? Stream settings. Here we go. Okay. We are. Where the fuck's my OBS? Here it is. We're good. We're cooking.
Awesome.
Okay, so you're on the coder pad. Let's get the show on the road. Just as a reminder, I'm not sure how familiar you are with the format. This is going to be a 1 hour mock. We're going to get right into it. So we'll spend 45 minutes to about 45 to 50 minutes, depending how we do, okay, on the actual problem. And then we'll have 10 or so minutes at the end for feedback and any questions you have. So the format of the interview will be different than a real interview, but we'll still get through the technical portions. Any concerns with that?
Nope, that's all good.
Okay, great. So for this problem, I'm gonna paste in. I'm gonna paste in a problem here. Honestly, I'm a bit late. I usually read these out, but I'm honestly a bit lazy, so I just don't want to do this today. Here's the problem. Please have a read. Please read out loud as well. And then when you're ready, please get started.
Okay, so design a data structure that supports adding new words and finding if a string matches any previously added string. Implement the word dictionary class. So word dictionary initializes the object. Void add word, which has a parameter word, adds word to the data structure. It can be matched later. And then we have a boolean for search word, which returns true if there is a string in the data structure that matches word, or false otherwise. Word may contain dots, where dots can be matched with any letter. Okay, so just looking at this for clarification, I'm just going to try to read it a few times to make sure I understand everything.
Okay.
So we are obviously initializing the word dictionary. This is the class. Here, so what we're doing is adding the word to the data structure so it can be matched later. So looking at here, that means that for this we're searching, once we're adding the words, we are searching for the word and then return true if we can find the word and false otherwise. And the word, if they have dots, that can be with any letter. And I think that should be it, just assigning the data structure to see if it matches any of the previously added strings. Okay, so for example, I guess I can start off by giving a few like test cases to see what we can get. Um, let's say I add like a word, right? And then maybe I add another word like board or something, right? So those are going to be added using the add word. And then when we search the word, um, it should return true or false if whatever word I'm searching here, if they belong in any of these words, that should be okay. And then we also have things like dots. So if I have another word, right, like with a dot, then that word can be matched as well. Um, yeah, so I guess another case would be if there's a word with like a bunch of dots, that's like an automatic match. Doesn't matter what this like the search word is. Is that correct?
Well, it has to have the right number of dots, right? Like if you,
Right, right. Okay,
yeah. But yes.
okay, that makes sense. Yeah. Okay, so looking at this, there's going to be, I think I can try to get started with some kind of plan. So looking at this, there's a specific data structure that we need to use to store these words.
Okay.
I think, well, like the brute force approach, right, would probably be the data structure would be an array. right? And then basically what would happen is we initialize that in word dictionary, right? So in um, our init function, we're just gonna have like some empty array like that, right? And then what's going to happen is every time we add a word, we're just going to add it in here, right? And um, basically, once we search, what's going to happen is that's going to be a for loop
Hmm.
to loop through every single word in the array, and then we have to once we check every word, we're also comparing every single character. So as a result, that means that by doing this, so add word is gonna have like an O1 time complexity because we're just adding a word.
Okay.
But for the search, we're actually going to have O n. So it's gonna be O n by m, where n is the length of the array,
Okay.
and m is so all the words like they can all be different sizes, right?
Yeah, they could be different sizes.
Yeah. So then this is just going to be the max length of a word, right? So the
Okay.
issue with this is the search function is going to take a really long time. So if are we like trying to optimize for spacer like time?
That's
Is
a good
there
question.
like a
We'll start by optimizing for time complexity.
okay, sounds good. So we'll
I wanted
optimize.
to, so is this what we written here? Is this for space or time?
This is for time.
This is for time.
Yeah.
Okay. Okay.
Yeah. Yeah, for space, it's just going to be whatever this the length of this array is. So all the words that we put into the dictionary, that's going to be the space. So I could, if you want, I could go with the brute force approach, but I think I can also figure out a more optimal approach. If you want me to explain that,
Do you
or
have an
I could.
idea of a more optimal approach?
Yeah, for sure. So another data structure I could use is called a trie. Basically, what's going to happen is what I can do is I store. I'll have. I'll create a new class. So this is our data structure. So I'll create a class called trie. Um, Also, it's okay if I like I can like create more classes. I don't have to stick with
Yeah, you can create
just
as
the
many
word.
as you want. Yeah, that's fine.
Okay, so I'm gonna start off by creating the class trie, and what variables we're going to have is so we're going to have um so a list of children, right? And then what's going to happen is each so we're gonna have a list of children. We're gonna have the actual value, and so in this case, what's going to happen? Just looking off of this, how this structure is going to look. So if I want to store the word, um, it'll be like a W. This might be a little hard to show from
You can
typing.
use a
Is it okay?
You can use a drawing menu on the left.
Yeah. So, okay. So what's going to happen is if I want to store the word, it'll be W, O, R, and D. So it should be like that. And obviously we can have like some kind of root because in case like for example board that starts with a different letter, so we can go B and then O, A, R, and D, and so on. So another like um, example that we might come across, which can be an issue. Um, well, not necessarily. This won't be an issue, but like say like we had a word that starts with the same letter, that's fine,
Okay.
right? But let's say we had word, and then we also had another word, which is word with an S. So in that case, how that would be stored is just adding an s at the end. But that could cause an issue because then we don't actually know if the word is stored or like word with an s is stored. So that could be an issue. And one way we could try to actually solve that issue is maybe having some kind of flag where we can say that this is an end of a word and this is an end of a word. Does that make sense?
Yeah, that makes sense.
Okay, I'll go back to the coding board. Um, so that means for the value, we're also going to have Boolean that says end of list, and that'll have some kind of value. We'll initialize it with false, and then only for some values we'll actually make it true. So this should be our trie class structure, and how this is going to work for our actual like word dictionary. So what's going to happen is the word dictionary will be initialized with a root, and then in the add word, we're actually going to not just like add a word, but we're gonna do it accordingly. So that's going to be so this is going to be like add word, and what's going to happen is we're going to take it's going to be like for some for every character we're going to start off with root, then it'll go to every character, and then we have to make sure we're storing it accordingly. So this is all going to be done in the add word, and then at the end we need to say that this is end of list. So that's
Okay.
going to be an add word, and then what's going to happen is for search word, how it's going to work is we're going to start off with the root, and then for the child, we're going to check. So we're going to compare the character of. So this is going to be the character for the parameter, and then we're going to compare that to whatever letter we can find. So in this case, what's going to happen is that's going to start off with W, and we're going to see is does the root have a child named W? So it does, and then because it has one, we're going to keep going. We're going to keep going down the list, and then basically once we reach here, the letter D, and that's the last letter, we're going to check is this the end of the list, and if it is, then we have the word and we return true. So, in terms of time and space complexity, so add word is definitely going to be more than O of 1. Um, that will probably be O of M, meaning where M is the length of the word. So because the reason why is because we start from root, and then for every character we're gonna add it to the list and keep it going. And then for search is gonna go from O of n times m to also O of m, because when we search the word, we check if there's some, like, we have to check each character and then go down accordingly. So that can be I might have to look into this again. I think
Okay.
will have a clear understanding of the time complexity when I code it. But right now I'm gonna say O of M because you're gonna look through the root, and then you're gonna check so basically the issue that I'm thinking that it might not be O of M, because if there are multiple words, then what's going to happen is we have to search through all those characters, and then every time we go down we still have to search through all those characters. So I might have to look at that and see if that adds any time complexity based on my code. But in terms of space complexity, that is gonna go up because we're storing all the words in a trie. So actually, I don't think it'll go up. It'll still be every single word. It should still be all the words. So the space complexity won't change from the brute force. But I know that the add and the search, so the add is going to be slightly more, the search is going to be slightly less compared to the brute force approach. Does that make sense?
Yep, that's fine.
So should I try building the solution?
Yes, please go ahead.
Awesome. So just gonna copy these and then sorry. Um okay. So we have word dictionary, we have our add word, which is a void, and then this is Boolean. Okay, and then before that, I'm gonna start off by doing our try class. So we'll call this try node, and then we're basically going to initialize um, this, where we start off with our list of children. So that's just going to be some list. Oh, I could probably make this instead of it being a list, if I make it a set, then that shouldn't add the time complexity to the search through every children. Because going searching in a set, that should be a one time, and then on a list should be O of n. So I'll use children for now. And then we also have our value, which is basically going to equal some character.
Cool.
And then we can have our end of list flag, which is going to start off by equaling false, and then if otherwise, we can change that. So the other thing is I should probably also have value as a parameter because we want to store that parameter. And then as a default value, we'll keep it as empty. So now that should be our try node. We're going to develop the class. So we're dictionary. We also have to initialize. So we're going to initialize with our root, which is just going to be a try node. So this is our the start of our try node, and we don't need to pass anything. So that'll be it for that, and then we are going to define add word. So add word had a parameter of word. I'm just going to double check that. Yeah. And then, so what we're going to do is we have to define how we're going to add the word. So what's going to happen is we're going to say for every character in Word, this should do that. Okay, so for every character in Word, we're going to store it. So I also need to keep track of the node we're currently at. So I'm just going to create a variable called node, and it's going to start off by pointing to self.root. So what this is going to do is this is just going to help us traverse through the entire thing without without like actually messing up the root node itself. So now that I'm here, what's going to happen is we're going to say the node um, children, right? We're going to add a new trie node, right? And that's going to contain the value, which is the character. Um, oh, I didn't make this. This is supposed to be a set, not a dictionary. So what this is going to do is this is going to say that now C is in, for every C in word, we're going to add as a child. And then basically what we're going to do is now we have to traverse through, we have to make sure the node is now pointing to this new node. So to do that, we can say node dot children. Okay, so looking at this immediately, I can see that our issue is that I won't be able to actually grab the child node. So I think we do have to use a dictionary because then I can use um, the value as, so I can have this as the value, which is character, and then the sorry, key is going to be character, the value is going to be the trie node. So then that'll allow me to keep going through because this trie node is going to have the other children its own value in the end of list. So so I'm going to change this back to a dictionary. And then what's going to happen is I'm going to say that at C is just going to equal a trie node. I'm also thinking that maybe we don't actually have to store a value. I'm going to keep it for now, but I'm thinking this is redundant because we already have it in the key, so I don't think we need to store it in the value. But I'll keep it for now, and then we can make that change later. So now that I have this, I'm going to now store this as the new children. So now node becomes the current children. So basically how this is going to work is we're going to start off with the root, then so our node's going to start here. I'm just going to take this to use this, bring it down here to explain it. So what's going to happen is our node is going to start here, right, at root.
Yep.
And then what's going to happen is we're going to originally this is just empty, and then we're going to say that one of the node's children is going to be C, and that's some other child node. So then what happens is now node is going to point to this trie node, right? Does that make sense?
Yep. By the way, if you're talking to me, don't worry about me. I understand it. Just please continue
Okay.
if you're confident in your solution.
Perfect. Okay. So then, yeah, it'll go from word, and then basically what happens now that we have to cover it, at the end of the word, we have to mark it as end of list. So that happens at the end of the for loop. So what's going to happen is we have to, once we add the last child, we're going to say the node dot end of list is equal to true. So now, so that's going to be the add word solution. And now we're going to go into the search. So for the search, we also have to do like a similar loop where we're checking every character. So we're going to say for every C in word, we're going to say that we also probably need to keep track of where we are in the whole structure. So we're going to start off with node, and then basically we're going to say that C. Um, so if um, C is in node.children, so we're checking if it's in the set, then we can actually do something. I can change this to no, I'll keep it like that, and then the case that if it's not in the children where it is currently, then um, we return false. And then I also have to keep in mind um, the case with the dots. So right now we're saying if C in node.children, or we also have to say that if C equals dot or node or dot in node dot children. So this is a bit long of a if statement. So basically, yeah, if so the only way so this is just checking if it's in um the children, or if C is actually like a dot, then we continue, or there is a dot in node dot children, so that means they automatically match. So if we can do that, then node um, so we might have to split this one up because based off of this, I won't be able to tell if we're at a dot or we're at C. So
Can you clarify what
okay,
you mean by you
I'm
don't
going
know
to
that?
yeah, for sure. So when I'm searching for the word,
Yep.
right? Um, let's say in the root we have a dot here, right? But C is um, equal to W, right? So I can't just say like if C like normally if C is in like the children, I can just use C as the key and then I'll get
Yep.
the trie now, right? But if this is the match and then I want to move to here, I need to know to use the dot and not C. Does that make sense?
That makes sense. I think you said it a little bit backwards, but what we're going to do here is we're going to say that the period is not a valid character of a word. So if you see a period, that means it must be the wildcard.
Okay. Could you repeat that?
Yeah, the only valid characters to make up a word are lowercase alphabetic characters.
Oh, like the parameter is never gonna have a dot. It's only gonna be from adding words.
Yes. The
Oh,
adding
okay.
the
So
add
then
like the words that are added cannot contain a period.
words that are added cannot contain a period. Okay, that makes sense. So then we don't need to cover this case. So there won't be any periods in the root itself. Um, so then that automatically means that node C. No, we need to make that. We need to change the node to node dot children C. So now we've changed it. So now we're just moving on. So we're like, okay, we found C. We're gonna move on. Now this is gonna keep happening, right? And we're just gonna say that if node dot end of word list, uh, we can just return it because it's a boolean. So once we found that word, we're gonna just return this, and that'll tell us if it's true or false. And I think that should be the result of the solution, looking at the time complexity. So yeah, add word
Can
and
we pause on that
the
for a
cert.
second? I just wanted to talk about this a bit more. So let's say we add the words. We'll do add bad and dad. Okay, and I want to search. Want to search this.
Yeah.
So in this, what should the correct value be if I search this?
Oh, right. Um, it can go to either one. Right. Okay. So I think that's also an issue with this one if the C is a dot. So that would have to um because the thing is that means that if it is a dot, we have to traverse through both of them, right? Because if let's say this was like dead and then we actually had this and then we're like okay, go with bad, then we're going to go through here and not find the word, but it's actually in here. So we have to cover that case as well. So that means that if we are doing that, we need to also we basically have to store kind of like maybe like a queue of um, children. So that would mean instead of having a node and then we're going to keep traversing through the node, we're going to have a queue, right? And we're going to store the root first. And then yeah, I have to import. Okay, so based on how this is going to go, we store it in the root, and basically, if the if C is a no children or C is a dot, then we have to add that to the queue. So we would have to this would only work for if C is a dot. So we're going to say that if so if C is equal to a dot, then we have to cover this case by saying that for every child in no dot children, we have to add it to the queue. So queue dot append child. So this is going to be a bit different because now I think I'm dealing with two different parts. Like I'm dealing with moving the node, but I'm also having like an entire list of children. So that's going to cause some issues. Um, so then what's going to happen is going with this example, um, we start off with checking there's a dot, and then we're going to add both B and D as children, right? And then we have to go through the entire queue. So for C in Word, so I'm thinking we can traverse. So for every character, we can traverse through the queue. And then within the queue, we check every single child. So child is equal to Q. So what this is going to do is we're going to actually check this child and see if the child that we have, which is going to be both, so they're both going to be A but different nodes. We're going to say that so we have the child, we're going to say that if child is equal to the character, then what that means is we have to so if it's equal to the character, then we need to move on. So to move on, we would
I want to ask about this
take
queue. You're using a queue
yeah.
for a BFS. Is that what we're doing here?
Yeah. Like
Okay.
yeah, BFS. That's what we're doing because yeah, we're looking through all the nodes and then
Okay.
making sure we can find the word. Yeah.
Okay. And your
So
condition for your BFS to continue, right? So you
mhm,
have your current candidates which are in this queue. You're saying
yeah.
any of them um, if any of them equal to your current character, you want to continue.
Yeah, so we'll add that child to the queue and then traverse through the queue like that.
Right, but if you add one child, like if one of them matches, what does that mean about all the
Hmm.
other children? Does that mean anything? Like, do you know anything about that?
So if it matches one of the childs, then that's the path we go with,
Okay.
right? Like
Okay, that's fine. Yeah.
in this case right here, like we have two options. So we have to make sure we cover all the children that match, right? Does that
Yes,
make
that's fine.
sense?
Yes, you can. Yep, that's right.
Okay, so yeah, so if the child equals C, then that means that we have to append. So we're not appending necessarily the child, we're appending the child's children. And so I'm just gonna bring this here and try it. So when we have the dot, we add um, our Q is just gonna have B and D. And then what happens is when we grab B and D, right? We're not supposed to be comparing. So we're not supposed to be comparing these characters. We're supposed to be comparing um, their children. So then this is going to be parent, right? And then we're going to say if C in node or parent dot children. So if it's in there, then we add the character to the queue, right? So how that's gonna work is now we check B. B only has a character of A, so we're gonna pop this and we're gonna add A, and then we're gonna see D also has the same character, so we're gonna pop that. That's also gonna have an A. These are gonna be at different points in the uh, entire like trie structure.
Yep.
So then what's going to happen is that's going to end, and then we go to the next character, which happens to be A, or sorry, no, the next character happens to be D, and then we're saying that if um Kyle, if the C is in the children, then we're gonna append it, right? So we pop A, then we push D, and then again we're gonna pop A, and then we're gonna push D. So now the issue with this is that we so our for loop is done. We've iterated through the entire word, but we still have the queue is still populated. Um, Another thing I forgot to count for is that we have to do this for the length of the queue before we start adding more things. Otherwise, the queue won't end. So this is going to be for just to hold the previous amount for the queue. Uh, so what this does is, so when I add um, like B and D, we're not going to be stuck in this um, loop. We're going to go back and we're going to check the everything again. So yeah, the issue with this is that we need to instead of popping like having the queue, I think this has to go in here because what's going to happen is we're going through, so for every character we're going to check the current queue and we're going to say if um the parent, we're going to say if the character is in the parent, then add it. Then we're going to check the next parent and we're going to add it. Then we're done this loop. And then we're going to come out here and we're going to say, okay, we're moving on to the next character, which is A. So,
Uh, is this supposed to be here?
oh, yeah. So this one, I'm just going to comment this one out.
Okay.
Uh, but this one is going to be in there. I'm just trying to figure out where I'm going to put this. And then this as well, like this entire thing is going to go in here. That's probably going to actually go in here. So like that. Um, so this is only going to execute if C is not in the children because it's a dot. So how this is going to go, I'm going to walk through this again to make sure I have everything. This is not the entire solution.
Okay.
So we have root. Yeah, so we have root. We're going to pop that. We're going to say that is the value C in the parent's children, and it is not, but C is actually equal to the dot. So we're going to say for every child in node dot children, we are going to add B and then we're going to add D. So the values we have here. So we add B and D, and then yeah, and then that was the end of that length. So then we're gonna go, and then the next character is now it's going to be A, right? So now we're gonna check is A in the children. It is for both. So we're gonna pop we're basically popping one, add A, and then pop D, add A, so it's going to end up like this. Our child ends up being D. So then both are the same. It's going to end up being D and D. And now this is where our loop ends. But our queue is still our queue is still has value, so this is gonna cause some issue. So we need to know that if in here, once we're done this,
Okay.
right, we need to check. We could probably do like we can do a while like queue and check every single value. We pop it and check if that's the end of the list, and if it is the end of the list, we return true. We could do it like that, and then if we get through the entire queue and then it's empty, we return false. The only thing that I'm worried about is like having this while queue and this while queue. I don't know if that's the best way to do it. I can code it up for now, and then
Okay.
maybe after we can. Yeah. Okay.
Yeah, that's not a big
So
deal. Yeah, yeah,
okay. Um. So we'll just um give it some name. We're gonna pop left from the queue, and we're gonna say if try dot end of list return true, and then we're gonna pop until everything, and then return false. So that's that. Then we don't need this. Yeah, we don't need this. This is never going to be executed. Um, yeah. So basically, what happens is when we're here, right? Um, this basically is saying that, oh yeah, we have some remaining letters left. We're gonna check. We're gonna pop this letter, and we're gonna say, is it the end of a list? And the end of the list is true, so we're gonna return true, and it'll end like that.
yeah. Okay.
So yeah.
Okay. Um, can we? Let me think. Okay, can we do time and space, please?
Yeah. So for like initializing is not gonna it's just gonna be O of one. This is so our time and space, right? So our time is going to be O of n. We're gonna say that n is the length of the word, and the space for this, I think the space is going to be how much words we add. So I think like this wouldn't be method specific. This would probably be like the entire um, trie structure. So for the entire like trie structure, that's going to be every single word multiplied by the maximum length of a word. So that would be n by m, where m is the max length of a word. And then I'll just say entire trie structure. So for the method for search, or the search function. So what's happening here is we go for every single um, character in the word. So that is O of M. Again, M is the max length of the word. And then we have our length of the queue. So whatever length of the queue is, which is the number of children there are. So we also have to, yeah, so for all the possible um, letters that are still in, so that specific level, so yeah, so I guess um, this specific part might be like um, we can say this can like best case scenario it can be O of 1 because there's only going to be like one character and we don't have to worry about the dot entirely. So if that's the case, this is going to be O of 1. It doesn't add any extra like time complexity. But say it does. So worst case scenario, um, it's going to be O of n because for the number of children. So like say so for the worst case scenario, would actually be this right here where we have a dot right after like so the root and it's just a dot. So the number of words that we actually have, that's going to be the length of this list. So that's going to be O of n. Um, this one is also for every child. So for every possibility, that can also be worst case O of n. So altogether, um, altogether that can be. So right now I'm trying to think um, if this is gonna end up always being a case because this is like so if it is this case and let's say we had like two dots that would be O of n squared here, but because it's like in an if statement it's not always going to be executed. So I guess like worst case it could be O of n squared, but I think average case it's going to be O of n by n.
Okay.
This is for time complexity, yeah.
Can you explain where the two comes from?
Yeah. So because in the worst, like this is for the worst case scenario. So worst case scenario is that we have a dot and then we actually have two dots. So that means that this entire for loop is getting executed. So in that case, basically what's going to happen is we are here where we are storing B and D, right? And then for every children in like for every like children from B, that's we're gonna traverse through that, and then for every children in D, we're also gonna traverse through that. So that can be like we're traversing through
Yeah, yeah,
n number of cows. So that's why it's like the worst case scenario because it is like it's
yeah,
only if they're not, but otherwise
yeah.
it should be
I'm still confused why it's two though. Like, is this better than having three dots?
So for three dots, um, if we had three dots, we would see that we'd add all the children, and then for every child, we'd add all those children, and then going again. For three dots, Like I think the more dots, like the worse the time complexity gets. I'm not sure if that would add an extra like n to the three for many dots. Like I
Okay.
looking at this, like I guess like because then we're basically checking if this is going to be n squared versus n like by n, I assume, right? Because this is three dots. Um, that means like the amount of dots that continue to be adds an extra like part to the time complexity. So just to kind of go through it, let's say, um, so we're gonna have like some list that is like length of n, and then we add n number of children to the list. I see. So like then for every n we add more children, right? And that's n amounts of children. So that does add a extra complexity. So I think
Yeah.
yeah, based off of that, that would probably end up being like worst case on by n if everything is a dot.
Okay.
Yeah.
All right. I'm gonna end the mock here. We went a
Okay.
bit over time, but we can still spare a couple minutes for the feedback. I've written the notes there, so send in the notes. You can read that in more detail.
Awesome.
What I did want to just say overall is just that I think you have some fundamentals here. You were able to spin
Yeah.
up the tree pretty quickly. Try, pronounce it try or tree, doesn't really make a difference. The main thing I
Mhm.
want to just talk about here in terms of what can be improved, I think there's two things. I think the first thing is to leverage your fundamentals that you do have and blitz through the problem, the easy parts of the problem, as fast as possible, right? Especially
Okay.
for problems like this one. Oftentimes it'll be that there's going to be like some easier parts, some harder parts. You don't want to waste any time on the easy parts. You want to get to that as fast as possible, right? In this case, when you thought of the tree, when the trie structure,
Mhm.
it's pretty obvious that the add word part is going to be the easy part, right?
I see.
So,
Yeah.
and hopefully you recognize that. If you didn't recognize that, then that comes with practice. That comes with some, conscious thinking about this, right? But hopefully, if you have seen this or this type of problem before, then that should be pretty obvious, right? So when you
Okay.
have that, that should not be taken any time. Like that should be done instantly. Okay. The hard part, obviously, in this case, would have been search, right? And you would have
Okay.
recognized that pretty early on. Now, a couple of things just before we dive into the search. Problem clarification. When you see the problem statement, there's obviously things you're going to need to clarify immediately. Okay.
Mhm.
The first thing you got to clarify is to go on autopilot. Okay. Just tell everyone this. Based on the types, like the programming type of the
Mhm.
objects that you're dealing with, there should automatically be a list of questions. Okay. If you're dealing with strings, automatic questions, length of the string, types of characters available, none allowed, null or Python's null and none, right? Empty allowed, right? Those should be automatic. You shouldn't even finish reading the question. Those should be questions that come out immediately. Okay, why is that important? Because you got stuck implementing a case for the wildcard where you thought the wildcard was a valid character. By the way, in the Leetcode problem that corresponds to this one, they actually tell you that the wildcard characters are not allowed in the add word. Now I didn't put it in there because that's part of the test, right?
Okay.
So that sort of stuff is very common. People want to get you on that because that's the kind of thing which, if you don't take care of earlier on, will make the difficult part of the problem much more difficult,
I
right?
see.
So those are kind of things that you just have to know immediately. Now, this is a string example. There's going to be questions you ask depending on the types. For example, if the input type's a tree, boom, null
Mhm.
knows, right? Is a search tree? Is a balance tree? What's the depth? What's this? What's the girth? Etc. So all these kind of things you got to be asking immediately, right? Those are the kind of things that will cost you 10 seconds and will save you minutes, right? So those are things you just have to know. Okay. Now I don't
Okay.
want to rattle on that like that's in the notes. Search. I'll briefly speak on this one. The implementation here was a bit questionable. I'll just say that just straight up. I think the first thing was that your original implementation, you didn't self catch that it was missing the bulk of the problem. Okay, um, that's a pretty big deal for problems like this because that kind of signals that you misunderstood like the problem, right?
Okay.
Like knowing the problem and then not being able to solve it is better than not knowing what problem you're solving and then producing a solution for a different problem, right?
Right.
Especially if at the end you're saying, oh, okay, well, this is done now. Well, that's not a good look, right? Now, I think there's a couple ways you can mitigate that. The first of which is just by running an example, right? So for add word, don't run an example. That's trivial. Just move on. For search, okay, that one, it's a bulk of the problem. You probably want to just check that your things are okay. And
Right.
especially if you're thinking in your head, right? Because as you're writing this, you should be thinking in your head, what's the space and time complexity? If that's not immediately obvious to you, you should be running an example to kind of buy yourself time to figure that out anyways, right? So, so for more difficult problems, you should be doing that right after you finish implementation. Okay, so that's the part I'll briefly mention there. Um, the actual implementation here, I mean, there's some stuff missing. I'm not gonna get into it here, but I want to just comment on a couple high level things. The first thing is that you're using BFS. Now I'm gonna ask you this: why did you decide to use BFS instead of DFS?
Well,
Was there a reason?
usually, usually BFS is used for like finding like the minimum path, but also I guess
Okay,
I don't think
so it sounds
it
like you
would
don't
like.
actually. So it sounds like you didn't have a strong reason to.
Yeah, it was just like it came to my mind first.
Okay, all right.
Yeah.
I'm gonna tell. I'm gonna work on this one a little bit because this is important. Okay, whenever these kind of problems come up, especially any sort of search problem, there's always going to be a lot of different techniques you can use. Right at this
Mhm.
level, the two most common ones you get is BFS and DFS. Okay,
Right.
now when you get more advanced problems, there's going to be a whole bunch more. So while it's still BFS and DFS, we can keep it simple. All right. Now
Mhm.
I'll give you the answer to this one. When should you use BFS versus DFS? For problems like this, it's very obvious. You should always use DFS. Why? DFS only weakness is that if there's cycles in the graph, you can use extra space. So if there's cycles in the graph, you probably or graph it's more general. If there's cycles, you probably don't want to use DFS. Now this is a tree. In a tree, you're guaranteed there's no cycles, so there's no
Right.
downside. Now the other thing you mentioned is that BFS, if you do it correctly, that is a caveat by the way, you have to implement it correctly. If you do BFS correctly, it is guaranteed that the solution it finds is the shortest solution. In DFS, the first solution you find is not guaranteed to be the shortest. That is true.
Right.
However, what is the problem? We know the length of the solution. It must be exactly the length of the search query. There's no such
Mhm.
thing as shortest or not shortest. All solutions are correct, right? So this is the other downside of DFS, which is also mitigated by the problem specification. So
Mhm.
because of these two conditions being met, you should use DFS. All right. So you can go back and read and just review DFS versus BFS a bit more. You can go learn about that one. But for this problem, especially for any search problem, they're going to see you're using BFS. That's going to be mark stocked on the spot because you didn't understand which search to implement, right? So
Okay.
if you have any question about that, let me know. But I mean, let me know DMs after. But I'm just letting you know that this is one of those things where it's like, yeah, it's not like a big deal, but it's one of those things where they just like an interviewer can look at your solution and go like, okay, he doesn't actually know what's going on. Like, oh, he doesn't understand search, right? So this is what separates strong candidates. Is this sort of stuff is second nature. And by the way, they'll actually call it out as well, right? They'll go like, oh, I want to use a search algorithm. Oh, I have these three options. What should I use? Well, let me look at the problem. Okay, the problem's a tree. There's no cycles. Okay, we know the length of the search solution. It must be exactly the length of the search word. Okay, so in that case, we'll just use DFS. There's no downside, right? So that kind of stuff needs to come out, and then you'll be a much stronger candidate because the interview goes like, okay, this guy obviously understands how to use search. They know what to do, and then it comes out easily that way. And I won't get to your implementation here. There's a couple of notes I had in my notes that you can read on later, but um, keep it simple. You have a lot of
Okay.
cases going on here, and that doesn't mean it's wrong. Like sometimes it can still be right, but if you're doing so many cases, you're having a triple nested loop, right? It's
Yeah.
like okay, what's actually going on here, right? This sort of stuff really shouldn't be happening for this difficulty of problem, because I feel
Mhm.
like once you start trying to when you start beginning to write a triple nested loop, you should be going like, okay, hold on a second, right? Like hold on a second. What am I actually doing? Why do I need a loop 3 times, right?
Hmm.
So just be aware of that. That's going to be that's going to bring question to the approach.
Okay.
I won't get to the rest of the stuff here. Obviously, you can read that async, but I want to give you a couple minutes here in case you have any questions for me or about the problem.
Yeah. I guess first question, was this a like a hard Leetcode problem or was this a medium?
No, this is the way it's asked here was a medium. Um,
Okay.
the follow up would have been a hard, but
Oh,
usually even for this, I start medium just to make sure we're kind of getting there, and then I usually go to hard after. Yeah,
okay.
I'll send you
And
the Leetcode
then
problem as well after. Yeah,
oh, perfect. Yeah, because I think I have done this one before, so I think I gotta review it again. Um, but yeah, the first question I wanted to ask was like, in like technical interviews, like, do they ever ask like concept-based questions, like non like data structure algorithm questions, I guess.
um, the answer is directly speaking, usually no, but it'll usually be tested via this method. Like for example, right? I'll give you a very small example just to tie it into what we're doing here, right? For the search
Mhm.
one, the like aside from the algorithm being probably incorrect, to be honest, um, the coding style here is relatively not great. Okay,
Yeah.
what should have happened here is you recognize this is a DFS. Okay, let's say you don't recognize that either. That's fine. Okay, but let's say you recognize system search, and that this is a problem which can be broken down into recursion. So what you should have immediately done is written a recursion helper and then use that. Right? If you're not going to track the nodes correctly yourself, a recursion uses the implicit call stack that's going to track it correctly for you. Right? So it's a case where like, okay, separate from the algorithm, the coding style and the code quality essentially, that's what it boils down to, is going to matter. Right? Another instance that was tested over here, by the way, this is also not algorithmic, is that you have a bug in your ad word. Now, the bug here is that you're overwriting the tree nodes, which is incorrect if the children currently exist. And it's incorrect because it currently exists for 2 reasons. The first one is because you're wasting memory. That's just not good code. And the second reason is
Yeah.
because you're overwriting a potential property, which is the end of list, which you're not copying over, right? That kind of stuff
Yes.
doesn't depend on your algorithm. That depends just depends on how clean your code is, right? Like how well you understand your own implementation, right? So a
Right.
lot of those things can be like they will not be asked explicitly, but they can be tested implicitly through your implementation.
Okay.
Did that answer your
That makes
question?
sense.
I'm not sure if I covered everything.
Yeah, that did.
Okay. Okay.
I
Good.
have I guess like two more questions.
Sure. Yeah. Go ahead.
So it's like does like the number of questions kind of tell you how well you're doing? So like for example, like you mentioned like there was a follow-up question and I think like sometimes people get asked like more than one kind of like leak code problem. So does that
Yeah.
usually tell you if you're doing better?
So that would depend on the company. Most of the company interview forms are known, so you can always ask in the community, and they'll tell you how many questions they expect you to do. Usually
Hmm.
speaking, if you're going for a more difficult company, you will be
Hmm.
expected to be asked in a 1 hour session 2 questions.
Hmm.
Now, the 2 questions can either be two completely unrelated lead code questions, or what
Hmm.
I usually prefer to ask is I usually prefer to ask one lead code question and then make it more difficult if they pass the first part, right? That way it's less context switching. But I would say you should prepare. You should be able to pretty comfortably solve any two medium problems in 1 hour if you want a good chance at those companies.
Okay, that sounds good. And then my last question, I think I kind of know the answer, but I just want to ask just to kind of gauge where I'm at right now.
For sure, yeah.
But like, yeah, based off like this interview, like how far away would I have been to make it to the next round? And like, what are the key, like, was depth first search, not using depth first search in the code quality, like the key things
I would
holding
not
me
say
back?
that's a key thing. If you had,
Mhm.
I think, I mean, you can use BFS for this problem, but you just did
Mhm.
not implement it correctly. Like this is not a correct implementation. So I think there's a
So,
couple of things that would have been needed to move to the second part at least. And it's not that you have to get to the second part to progress to the interview loop, but it's just that in this example, the bulk of the problem is in the search function, and
mhm.
the first implementation you gave up, that you produced, was too far from being correct. That
Oh.
was like a major, like a negative signal, I would say, in that
Mhm.
you didn't detect that that was the main problem and that you did not correct yourself, right?
Okay.
That is by itself already a questionable kind of like part of the interview. And then once that was pointed out, right, we're working on the right track, right? Now the code quality kind of fell off, right?
I see.
There was a lot of I would say unnecessary manipulation with the loops, right? You started off correct. I mean, there is a way to do it correctly with a while queue at the start, right? But it's unnecessary, right? So it's like, okay, this guy didn't really understand why they had the looping through the characters first. Okay, now the queue management is off. Now the queue management is all over the place. Now they're doing all the other stuff, right? And then okay, now to fix the queue management, which he actually did realize was a problem, by the way. Now we're doing this, right? Which is okay. Well, this might fix the queue over there, but then we're choosing a new problem, and then you recognize that was a problem as well, and then you're doing a kind of band-aid fix over here. So it's like, okay, I can see where the mindset is, but this is like not what we would expect from a BFS implementation. So the
Mhm.
idea is there, the implementation is definitely not, but with more time, this can be made into the correct implementation. Although for the intended follow-up, this would have been untenable, right? So there
I
is
see.
there is a desired path of least resistance, which we expect people to do. And typically speaking, if we had more time, I would actually correct this to get on that path again, right?
Mhm.
But with how the search function started, I thought, okay, we're not gonna get to the second part. That's okay. We'll just see how far
Mhm.
we can get on this one part.
I see. Just as a follow-up question. So like say like I was doing this and I was like struggling a little bit and
Yep.
then I decided to switch to a DFS solution. Like is that really bad? Is that worse than continuing with the BFS or if I switch would that have saved me?
In this case, it wouldn't have made a difference because your difficulty isn't actually with your difficulty here is with the implementation of an algorithm. So unless
Mhm.
you're much better at implementing DFS, which I find to be weird, I mean they're the same thing just with a different structure. Um,
Yeah.
then I would say probably it wouldn't have helped you.
Mhm.
How you should determine that in an actual interview should be based basically entirely on how far you think you are from the current solution, right? Like, okay, let's say you're
Okay.
doing this, you got about 10 minutes left, right? And this is
Mhm.
what you have on the page right now, let's say, right? Okay, you're like, all right, I know this is currently not correct, or it's maybe correct, but like barely. There might be some other edge cases I'm missing, because you got to realize
Mhm.
that I did not give you all the edge cases yet, right? With the problem,
Yeah.
so like,
Mhm.
okay, this is not great. Let me think. If I want to go, like, what else could I do? Right? Okay, and because you're thinking, okay, well, I could do this in DFS, but what would that change? Well, I would change this from a pop left to a pop right or whatever, right? Would that make
Yeah.
my job easier? I don't know, not really. It's the exact same code, right?
Mhm.
So in reality, I would say DFS would not have saved you here. When it would have saved you is you're like, okay, when you had your original loop, which you don't have it here anymore, and you're thinking, okay, I need to add all my nodes to a structure. What structure is going to help you the most? If at that point you were already set on either BFS or DFS, then DFS likely would have actually helped you there because you wouldn't have needed to do all the queue management in a sense. The logic would have been simpler in that, hey, as soon as you hit any children node that contains an end of list after you exhausted your word, then you should just immediately return true, right? That would have likely saved you a bit of effort, but you would also had to have realized that earlier on in the process.
Mhm.
So I would say it's really hard to say. It's hard to say not because right now it's hard to say. Right now, I mean, I'm telling you, yeah, DFS is better, but it's hard to say because when you need to make that decision, you need to rely on your past experience and your knowledge of the problem to be able to correctly deduce what to do. So could you have done that earlier on? Maybe. It's hard to say.
I see. I guess another question I can ask. So like I noticed like yeah, my code quality like was pretty bad, especially with the multiple nested loops. Like for practicing, is that like is there like a better way for me to practice to avoid that or is it just like it comes with more practice?
I mean, everything comes from practice, but you can definitely practice more intelligently.
Yeah.
There's a lot of different techniques to practice this kind of thing, and it's hard to know which one will fit you the best. But I'll give you one which I
Yeah.
don't see mentioned online very much. By the way, you should go online and see, okay, how do I get better code quality? What should I be practicing, etc. But I'll tell you one I
Yeah.
don't think people do enough, which is do problems. And by the way, I think actually better problems to practice this on are more object-oriented design problems. Like this problem we asked here is like halfway between Leetcode and object-oriented design. Practice both. It's all good, right? But the tip here is start trying to make a solution, and when you
Hmm.
realize your code quality is bad, finish it anyways. Like just write the bad code, finish it anyways, and then immediately redo the entire problem. Immediately redo the
Okay.
entire thing with all the insight you've gained from being forced to write the bad implementation, and
Hmm.
then compare the two, right? Hopefully your second one's much better. And to think to yourself, okay, how early on in the problem could I have caught this and have instead pivoted to the better solution, right? What would I have had to know? Like, is it that I had to know that, oh, this is a queue. Oh, wait, queue, I need to do it this way. Or is it,
Hmm.
oh, I'm writing, a helper function with these parameters. Oh, then I should have done it this way, right? Like, try to see when you compare them how early you could have detected that you should have done something better, and what could have triggered that thought, right? I think a lot of people are always being very prescriptive in saying, oh, if this, do this code, if this, do that code. No, I think in reality that's basically just memorization, and you can never memorize every code pattern, right? You're better off just learning it through yourself by forcing yourself to finish bad code and then redoing it in a good manner. So I'd say see online, see what other people recommend, but that tip I think has helped a couple people in the past as well.
Okay. That sounds good. Yeah, that's probably all the questions I have. But yeah, thank you for doing this. I appreciate it.
You're very welcome. All right, take care.
Yep. Bye.
All right, we went a bit over time there. That's my bad. I mean, I think this person could have learned a lot, so I just wanted to make sure. Just want to make sure that this person got the help they needed. So again, they were also on the line for a long time, and they were very responsive in the DMs. So want to reward that a little bit. Anyways, we are still doing resume reviews. I'll give some more time to the community so we can get through them as we need. So yeah, good question in the chat. The follow up, by the way, there would have been supporting the regex dot star, which is having one dot recommend 0 to many arbitrary characters. The hard version of that problem, by the way, that is actually a variation of another Leetcode problem called prefix and suffix search, I believe. I think that's the name of the problem. And that problem requires you to search both from the front and the back. So that would have been the follow-up, is supporting, instead of like arbitrary number of periods, support one dot star. And then the follow-up to that one, which would be diabolical, and I don't even think I can do, to be honest, is supporting arbitrary number of dot stars in the string. All right. Yeah, I mean, sooner or later, you're just literally writing a regex parser. That's definitely not a Leetcode problem anymore. What am I doing? Resume sheets. Okay. Where the fuck is my resume sheet? Here it is. All right. Resume form. Submit. Submit this form. Resume. Forms.google.com. Where the hell is my form? Oh, I'm in the wrong account. I see. Yes, this one. Boom. Submit resume. Oops. I copied the wrong one. Submit resume. Boom. Alright, what are we doing on this beautiful day? Beautiful December 6th. On this beautiful December 6th. File, download. Alright. Oh, this person was... Oh, where the hell's my downloads? Here it is. Alright, this person was on the stream like a couple months ago, I think. I remember some things here. Do I? Well, maybe I'm lying. No, I think I do. where's my stream? Okay. All right. So let's see. Focusing on embedded suite infra. Okay. Let's take a look. Let's use green today. This is present. They started December? Okay, well this is still new. Literally 6 days, so okay, nothing to say. Okay, Bach, even if for okay. Platform. To improve search efficiency. I would like to see some numbers here. Would like to see numbers here as well. Valet API, I never heard of that one. Okay. PHP unit test. MLOps, MLflow, Databricks. Okay. This is good. Deploy that, improve this, but also some numbers here. I think you're lacking some numbers here too. Okay, see numbers over here, but you want the recent numbers if possible. That's gonna be a lot more relevant. Sure, using Postman. This was a bit weak, to be honest. Like this is just like, I feel like this point is okay, but unless you are able to quantify it, it's really hard to say how relevant these APIs are, right? Geo comply. Okay, this one I remember. Yeah, this is all fine. This is nothing too groundbreaking, but this is totally fine. Let's get a date over here. It doesn't address the lack of real-time attribute specific validation service. Okay, this is cool. I like that. Good project. Oh, you have a link over here. Okay, but I was still recommend putting a date here, right? Most people who are reviewing resumes, they couldn't give less of a shit about Minecraft. So put a date over here. No one's gonna click that. I would click that because I like Minecraft, but no one else is gonna click that. This is all fine. Okay. This is gonna be by some distance the biggest piece you're gonna be working on. This is gonna be your big break. I see some SWE is good. I see some infra is good. I don't see embedded at all. So unless I'm misunderstanding what you mean by embedded, I think you should probably work on some embedded projects or something. But I mean, SWE is good. I see some bit of infra here as well. Infra could be good. You mentioned Docker here, yeah. So you have maybe a tiny bit of infra over here, but realistically speaking, if you want to be competitive on infra, especially as a third year going in next year, you are gonna need some infra projects. Thankfully, infra stuff is easy to do these days because how cheap these platforms are. And when you do infra projects, just keep in mind, there's a lot of tutorials out there. There's a lot of support out there. There's a lot of good templates to use. So I think you could definitely boost this resume up a little bit with better projects. Right now, this is a pretty generic resume. It's not bad. It's pretty normal, pretty solid. But I think embedded and infra is going to be a bit far off. All right, that actually was the only submission today. I think maybe I kind of stalled too long. I think I waited too long. Let's see. But I will wait. I will wait a bit. Let me see here. Submit resume and pinned comment on YouTube. Commento. All right. Leave this over here. I'm gonna get some water. Don't hurt yourselves. All right, did you guys injure yourselves yet? Thoughts on putting a topic slash overview before point content, ML ops or whatever. Topic overview before point content. Oh, you mean like this guy? This stuff is fine. I mean, I don't really care. Like this is the kind of thing which might help like people who are unable to read a little bit more, but I don't think it matters. It's not good or bad. It's just fine. All right, let's see. Still no submissions. All right, let me go advertise a bit more. Where do I have mod permissions? You guys are already from TCN. Yeah, y'all already chilling. Let me take a look. How about Boba Talks? Can I advertise there? Let's see. Tech careers. Oh no, wait, I put it in. Oh no, I didn't freaking put it in the wrong channel, bro. I put that shit in the wrong channel. Whatever. I'm also doing resume reviews. Reviews for the next 15 minutes. Join in or else. Yeah, threaten people. That should be good. Yeah, I was gonna hang until like 1:45, and then yeah. We'll get some blah blah blah. And then who's paying me? You dare ping me? Who is this? It doesn't matter. Okay, what's this? Doesn't matter. Okay. Dude, all these DMs are just pure spam, bro. What the heck? Alright. I mean, I am going to wait here 15 minutes. So if you guys got nothing to submit, I'm going to sit here and just like browse Reddit or some shit. I don't fucking know. Oh no, I should probably answer my DMs. Alright, let's take a look. What is this? Hi. Wave hi. Alright. I don't remember why I don't read my DMs anymore. Okay, let's go to my friend request. He's got to be better, right? Let's take a look. Who is this person? Oh, you know what I'm gonna do? I'm gonna frickin' do my admin and code while I'm waiting, bro. Holy cow. Read chat and do admin and code. Holy, this is a good life. Where's my VS Code? Oh shit, it crashed. Okay. I am waiting for submissions until 1:45. All right. Day 6 is last night, right? Wait, why is my... Oh, okay, I think that worked. Holy. Holy, yeah, we're just doing anything in the chat now, bro. Fuck it. This shit. Wait, I could probably make this like a double stream, yeah? Hold on, let me see how I can do this. Notepad. No, let's change from Notepad to this. Right? And it, oh shit, I fucking closed my windows. Okay, hold on. Freaking hell. Okay, there we go. And then what I can do is I can make this, I can close this, get rid of that. Let me make this thing like skinnier. Scuffed ass stream, dude. Oh, shit, how do I make this skinnier? Okay, there we go, that's skinny. And then do this. Then I can move my VS Code in here now. Oh my god, professional streamer alert. Holy shit. Holy shit. And then I can do admin code. Where's my mouse? My mouse is gone. Oh, okay, it's back, it's back. Okay, you are my thing. Okay, let's take a look. Day 6, day 6. Copy this guy in here. Oops. What the? Did I not copy it? There we go. Alright, what are we looking at? Dude, this is so fun. I should do this on stream more often, dude. Trash compactor. Okay. Find garbage streaming. Doors magnetically sealed. Oh shit. Cephalopods. It's a list of problems. Each problem is a group of numbers that I can't see the problem. Why is my taskbar open? Okay. Be either added or multiplied together. However, the problem arranged so a little strangely is going to be presented next to each other in a very long horizontal list. Did I copy the format correctly? Is this how it looks like? This is how it looks like. Okay. Each one of the numbers arranged vertically upon a single operating form. Problems are separated by a full column of only spaces. Left-right alignment of numbers can be left-right alignment. Okay, okay. So the worksheet. So these are multiplied together. These are added. These are multiplied. Okay, okay. Grand total added to all the answers of the problem. Worksheet grand total is this. Of course, actually run flatter. I don't know, completely. Okay, okay. All right. So this is just unfurling a vertical separated list. Okay, we can do that. So let me get the example together here. Which is over here. How to open this? I'm still learning how to use VS Code. So let's get that going. Whoops. Wrong one. I need this one. Okay. So this is each line, and then I need to know how many num calls equals lines 0 dot split on, like, what is this, space? 10 num calls. Oops. Okay. Let's see if this works. Open test. Right. I need to change 2025-06 question mark. Okay. Oh, it ends in a space? Okay, so x dot trim for x in. Oops. Does that work? Do you mean strip? I did mean strip. Wait, if it knows I want strip, why doesn't it just do it for me? Oh, so it's double. No, it's any white space. So can I do like this? Is this regex? Python split string on white space. Oh, it's just split. Ah, okay, well, that's freaking okay. Not num calls. Guess it'll be the line. So this is how many we want to maintain. I should probably check if I had submissions now. No, no submissions. All right, we're continuing to do admin code. Fuck this. Okay, so I want to parse this. So I need to have, let's say, nums, and then I can just read them vertically, right? So yeah, it doesn't even matter. So I can do for row and lines nums dot add. Is it append? Yeah, it's append. Is it extend? I think extend, right? And extend it with an iterable. No, I think it's a, wait, I don't want. So this would be the current line, which is row dot split like this, and then let me see what nums looks like. Yeah, exactly. I want to map all these to numbers though. Yeah, I want to do all these to numbers. So int x for x row dot split. Did I do it correctly? No, I need here, I think. Let's see. Ah, right, I see. Okay. From 0 to len lines minus 1. Len lines minus 1. There we go. And then I want the operators equals this, and this is just equal to lines at last line, right? So print operators. Yeah. Okay. Cool. Oh, this is not stripped though, so I want these to be stripped as well. So strip dot split. Yes, that's exactly right. Okay, so what we're trying to do here is we want to iterate through them column wise. So let's do, did I have that? I had that. So this is going to be, number of columns I have is X, and then Y is my lines. This is just a convention I use. So for X in range X, for Y in range Y. No, this should be -1. Don't count operators. Let me just, who pinged me? Who pinged me? You. Alright. Tell I gotta stop spamming my ass. Any submissions? No, we still, okay, let me refresh. I do not trust Google enough to know this live update. Nope, still no submissions. Okay, that's chill. I'm more than happy to just continue working my admin. I did not get to do this yesterday. Okay, so right, and I need to do the operator. So cur op equals. So we'll do, this is per x. So right, so this is per op equals operators at x, and then and equals 0. Start. This is additive, right? So yeah. So if cur, it's only times and plus, right? Only times and plus. Okay. So if cur op equals, let's do plus. So and plus equals some. I want lines. Oh, this would be a column, which I don't think I can do like that. Okay, so do it this way. Per nums equals this. Per nums dot append lines at y at y at x. Okay, and then if I were to print per nums, I should see. What should I see? Let me not print this. That doesn't look right. What did I do wrong? These are all strings. What are these strings? Oh, because I don't want lines. I want frickin' nums. Right? Is this correct? I want 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, that's correct. So I want to just do and plus equals. Well, let's do this way. If cur op equals plus, I want to and plus equals sum for nums, right? And then else, this is multiply, right? And plus equals. Is there a mul? Really? Okay. Plus equals. Oh wait, Python must have a multiplier. Python math.mul. There must be a mul. I don't believe it. Math.lcm. Really? No way. Oh, there is a mul. Oh, it's an operator.mul. Oh, it's math.prod? Hello, VS Code? Do I import math? Yeah, how does Python work? Math dot. Oh, here. Okay, I need to import. Dude, what kind of? I did not know how to import math. Not gonna lie. Not gonna lie. Print as. What do we expect for this one? The answer. What do we expect for this one? Is this? Ooh, it's wrong. Okay, why? Let's do. Oh, wait a second. This should be out here. Yeah. Okay. Okay, what's my input? Oh, that is a large list. Okay. I like it. Okay. Yay, correct. Okay. Any submissions? Oh, we have a submission. Yo, let's go. That's crazy. You got in just in time, to be honest. I was about to frickin'... Actually, no, we still had like 5 minutes. Alright. Oh shit, how do I do this again? Okay, hold on. What is it? OBS. So, let me just do... Oh, whoa. Don't do that. Okay, hold on. I'm gonna do... Yep, and now I'm gonna... How do I make this layer on front? Like this, I think? Boom. Oh my god, I'm so good at streaming. And then I need to take her resume, put it here, boom. Holy cow, professional streamer. All right, let's take a look. So, all right. So your prompt is backend / full stack 2026 new grad, big tech. Okay. Let's take a look. Got some stuff going on. Honors list 2 years, damn. Okay, not bad. Coursework, this is pretty decent. This is the kind of stuff which it's like borderline. Like I think this is not too bad upon the resume. Like stuff like this is good. This is good. This is good. This depends on what kind of stuff you're going into. If you're going into back in full stack, I don't think this is too relevant. DBMS is not bad, but better show don't tell, right? This is recent. That's good. Okay, nice. Some recent stuff. I like it. Okay, good. Okay, I set a vehicle in an inventory search by 90% when Java's completable features, Spring's cacheable, optimized complex queries. It looks so cursed to see the @ symbol in a non-code context, but no, I like this. Okay, that's good. Remediate system critical has okay, that's good. For Kafka Elasticsearch. Okay, I think this is good. That's good. I like that. You were here for 4 until 8, so 4 months. Okay, that's not bad. The first one feels like the best. This one feels like just killing time, honestly. This is not bad either. 10,000 plus vehicles. And this is fine, yeah. Okay, software development intern, this project. Okay. Diagnose, resolve critical data binding failures. I don't know if we should use, I don't know. It feels kind of adjectives, you know? I think just get rid of those, to be honest. Live production application. Render for end users within the live production application. I feel like that's kind of redundant to say that, right? Like this part feels redundant? I don't know. That's fine. Okay. Some stuff, last okay. School club, okay. Python Flask, 5-person agile. Okay. Okay, what's going on here? Okay, that's fine. Backend full stack. Okay. Backend, you've got some pretty good stuff here. You've got the Golang, you've got the Spring, you got Spring twice, right? You got Spring out here again, you got some databases. Full stack. Okay, what are we talking about full stack? You have this full stack, ensure accurate UI. I would probably elaborate a bit more on what tech stack the UI here was in. That seems a bit ambiguous. I don't even know if you actually fixed the UI itself or you just fixed the underlying data to make the UI work. That's a bit confusing. I assume it's a ladder, by the way. I assume it's a ladder. You have UI over here? No. What is it? Okay, this is UI, raw HTML CSS. So that's not going to cut it if you're going big tech. We need to have a good framework here, okay? What's this? Nothing. What's this? Nothing. Okay, so backend, it's looking pretty strong, actually. Backend, there's some stuff going on here. Full stack. I mean, you need a front end project. I mean, no other way to say it. What full stack web dev projects do you recommend to do if you only have C++ projects and want to expand to get sweet roles? Um, you asked me about what projects to do. I mean, the project part is the easy part, right? The thing is that especially in this level, you're not being hired to have unique ideas, right? You're being hired because you have the skills to execute on someone else's idea. So what you should do is you should pick your favorite social media platform and just make a clone of it as close as possible, right? And the thing is especially if you're trying to showcase skills, you make it online. People can log in. People can do some basic stuff, right? That's the strongest vote of confidence you can have. So don't worry about what project. Just pick any social media platform that you like and just make a clone. Stop thinking about that kind of stuff. Like just start, get to the doing part, get away from this thinking part. All right, let me just check my Discord, make sure things are okay there. Otherwise, I will. That guy's comment is irrelevant. What does this guy say? Is he? It's a different conversation. Okay. Otherwise, okay. No other submissions, and that's all. That's all from me. Take care, guys. What tasks I should use doesn't matter. Pick one that you can actually learn. If you want to open the most doors, you stay with as basic as possible. If you're only C++, here's the thing, okay? If you have the skills, I would recommend a more comprehensive stack that's a level above MERN. But if you don't know what you're doing, you're a student, you have basic C++ stuff, start with the easy stuff. Start with a MERN stack, right? Start with a MERN stack. And then after that, expand to a more comprehensive stack, right? I would say if you're trying to open doors, you got to use some pretty big boy things. For example, if you can have a project that has Spring Boot, Spring Boot's not that scary. You can ask this guy. Spring Boot's really not that scary, right? But Spring Boot, that's going to open a lot more doors. Okay, that's going to open a lot more doors. But here's the thing: is if you haven't used JavaScript at all, okay, start with a Node backend, right? You got to start with a Node backend. That's the lowest barrier to entry stuff. Yeah, Spring Boot, I think is the most. Here's the thing: you can pick Spring Boot, or you can go Microsoft Line. You can do C# ASP.NET. That's all fine. Start with a backend like that. Use a pretty big database, right? So use like a real database. I would recommend, if you don't know better, use Postgres. Always use Postgres. Okay. In the MERN land, MongoDB is a recommended one. MongoDB is way easier to use, right? If you just want to get started, again, MERN stack, MongoDB, nice and easy. Okay. But if you're trying to get the doors open, use a SQL database. I would recommend 10 out of 10 times to use Postgres. Okay. But it doesn't matter. You're doing a project, anything works. You can even use SQLite if you really want, but I would recommend Postgres. Okay. Front end wise, that's is where depending on where you're focusing on, keep the front end. You can, for example, if you're more back end focused, make a good back end and a bad front end first, right? And then when the back end gets really good, then work on your front end skills, right? So I would say start easy. You can just deliver HTML, CSS. That's all totally fine, right? Get some nice styling in the front end. You can use even Bootstrap, some easy HTML, right? And then when you want to work on front end skills, then pick up a real front end framework. I would recommend React. That's the most employable one. But honestly, any of them are okay. You could use you could use Angular. You can use Vue. Both are okay. If you want to, another thing you can do if you want to just really make it easy for yourself is you can just use Next. What's the other one called? Svelte. Any of those things. Any of those flavors are all okay. I would recommend keep it vanilla React, and then add stuff as you go. For employability, that's gonna be the best. Okay. Deploying products versus products just on GitHub depends on what you're trying to communicate. For example, if you're going for a full stack, you're going to need to deploy something, right? Like just having a GitHub pages, there's no backend there, right? There's no backend. So it has to be somewhere. It has to be deployed somewhere. Now, again, you can do it in a couple stages. For example, if you're new to all this, you don't know what you're doing, you can make an easy backend, right? Start with Firebase. Start with Supabase. Basically, no skill required. Very, very simple. Right? And you can go, okay, now you're a bit more comfortable with deployments. Now you move up to MERN. Right? Now you got to host your node. Where are you going to put your node? You put it on AWS. Put it on Vercel. I don't know. Do they have node? Right? Put it somewhere, right? And then now if you want to get a big project, now you should start want to handle some volume. I'm not saying that your personal project has to have 10,000 concurrent users always. I'm saying, hey, you have a nice design. this design can handle this many users per second or whatever, that could be a good thing, right? So then I would say as a proof of concept, move it to a real platform. Let's say move it to AWS for a day, run some tests on it. If you move it to a day on AWS, a day going to cost you more than $10 for that one day. Okay, like it's not that bad, right? Run some numbers, quantify it, see what you can do, and then take it off AWS so it doesn't cost you $10 a day, right? But it's one of those things where start simple, start at whatever level you're at, right? Start at whatever level you're at, and then and then improve it, right? What I don't want you to do is to start off huge ambitions and you just don't get anywhere because you don't have the necessary stepping stones to get there, right? So that's why I'm saying I wouldn't recommend starting out with Spring Boot if you don't already have backend experience, because there's a lot more you have to get started, a lot more you have to get wired in, authentication. I don't know, does this guy use Spring Boot? No, he just used Spring. Spring Boot authentication plugin, that's an entire degree worth of material, okay? So a lot of stuff you gotta know, but start simple, you're gonna get there eventually. Use SQL before, use SQLite. SQLite's very chill, but Postgres is better for employability, right? No companies need SQLite in the real world. All right, sounds good. Merge stack, learn AWS, do that, because I think learning some cloud platform is really important. Yeah, you need to. Yeah, I mean, this is what I'm saying. Full stack, right? Full stack isn't just I have a backend, I have a front end, there's an API. No, that's bare. That's like third year, fourth year level student material, right? That's not gonna cut it. If you're going big tech, you gotta have something better, right? So exactly, a full stack in this context means you also gotta do things like deploy it. What's the infrastructure like, right? What's the authentication like? What's the performance like? What's the observability like? All those things are going to be important. So I would highly recommend, right? Start simple, but then have the ability to do things like move it to the cloud, right? That's very good ability wise. Yeah, most people in the stream, by the way, most people in the stream are still in school, right? Most people asking here are still in school. So they're just getting there. All right, you love birds. Get out of my chat.